Hi, I'm PJ,
And I'm Steven.
and we want to demonstrate to you what we did for our ECEN 390 Electricity and Magnetism class. We set out to, we were given the task of demonstrating some electrical or magnetic principle. And so we chose to go with with one of Maxwell's equations, which we have over here. So we've got the curl of our magnetic field is equal to a current and also a changing electric flux, which we have demonstrated here. So as we have, we'll have a current going through here. This is conventional current flow, so bear with me. These aren't electrons. We have conventional current flow using the right-hand rule. We're going to have magnetic flux that flows in this direction here. And so during talking about this principle in our class, we had a guy pipe up and ask, why can't we use this principle in powering a vehicle or something like that? And we thought that was a pretty cool idea, so we took it and ran with it. So we came up with this schematic right here. This is what we've got. We took a transformer that we had about 40 volts coming out of that guy, and then we created a primary coil and a secondary coil. The secondary coil we connected to the bottom of a remote control car. We took that AC signal that we got from these coupled coils to a rectifier. Then we got a DC voltage out of that using this capacitor. We actually use a 1 farad supercapacitor there. And our motor was, this car was designed to run off of 6 volts. And so we decided to show that we could use a combination of EV technologies like batteries and capacitors together to power a car. So we augmented this with 2 AA batteries that we have in series here. So we have our voltage that we're going to get from that's induced here. We're going to add that to these 2 AA batteries to power our motor. If we go over here, we can see that we have built a track, our track of magnetic glory here. So this is our car. Let me show you our coil we have on the bottom here. Pretty clunky looking guy. And then this is our primary side. We've got a steel core going on here. Pretty big guy. So what we decided to do was to move our car along the track here, and with the AA batteries, it's able to move itself ever so slightly. So when it gets to this point, it'll will induce a voltage, and then it'll continue to move on. Let's see if we can get it one good time through here. See, we got nothing. But we can, we are having a lot of problems with just this, the physical restrictions that we have with this car and with this track. A lot of the problems we have are just the friction, of the sides. We're not getting enough power out of this motor with just the 3 volts going across it to get enough power to push it past. But you can see here, if we have this guy on, you see how it's moving okay, but as we move it closer to our coil, it really starts cooking. So we are getting a voltage induced across this one. But it seems like this was about the best we could do with what we were working on. So as you can see here, the distance between the 2 coils is pretty small. but we were still unable to get the transfer that we really needed. And that's because of this guy right here. This mutual inductance that we have between these two guys is based off of this. We're stuck at 60 hertz, so these two values are constant. But what we've been trying to fix and trying to maximize is this value right here, this coefficient of coupling, and that has been the real challenge. We've done a lot of different things to maximize that by increasing or decreasing the distance between the two coils, and changing the size and the shape of the coils, the cores that they use. But with not sharing a common core, we're just having too much trouble keeping that value high. So the amount of power that's transferred from the primary to the secondary side, it's really tiny. Really tiny.